Okay friends, welcome to Login Science. In this video, I'm going to solve question 7 on exponential functions grade 12. Okay, so this is a question from Gauteng 2019. Okay, it's question 7 from Gauteng 2019. Okay, on exponential functions grade 12. So you can use this question to practice. Okay, so question 7, you have 4 questions. You can see the total is 7 marks. Okay, let me get started on the next slide. So we start with question 7. Let me get the question again. It's question 7 from Gauteng 2019. Okay, so this is the question. Question 7, given f of x is equal to a to the power of x, where a is greater than 0, passing through the point, this point, and g of x is equal to 4x squared. Okay, you are given f of x and g of x. F of x is passing through the point with this coordinate. Okay, and you are told that a is greater than 0. Now 7.1, the question is 2 marks. Prove that a is equal to 1 over 2. Okay, you have to prove that a is equal to 1 over 2. Okay, so we are going to prove that f of x is equal to a to the power of x. This is what we are told. Okay, we are going to try to find a and see if a is equal to 1 over 2. Okay, and you are told that you have this point with this coordinate on the graph of f, because the graph of f is passing through this point. So you have this point on the graph of f. Okay, so the point with this coordinate is a point on the graph of f. Okay, we are going to use it to find a and see if a is equal to 1 over 2. Okay, now this is the x coordinate. The x coordinate is 2 and the y coordinate is 1 over 4. Okay, f of x is y, so y is 1 over 4. This is equal to a to the power of x. X is 2. Okay, this is x and this is y. X is 2. Okay, now from here what you have to do is to solve for a and see if a is equal to 1 over 2. Okay, what you can do is to take the square root of this, right, a square, so that you can remain with a only. This is equal to the square root of what you have on the left, 1 over 4. So you take the square root on the right and the square root on the left. And remember, you have to include plus and negative because you are taking an even root. So from here, you know that this is a is equal to square root of 1 is 1, square root of 4 is 2. Okay, so a is equal to 1 over 2, or a is equal to negative 1 over 2. Okay, now if you check the question, you are told that a is greater than 0. So a is not negative. A is greater than 0. This means a is positive. So let's reject this. A is not equal to negative 1 over 2. So only a is equal to 1 over 2. Okay, a is equal to 1 over 2. So this is the value of a. And we have proved that a is equal to 1 over 2. Okay, now 7.2. Let me draw a line here. Okay, so 7.2. Okay, let me do this. 7.2, determine the equation of y is equal to the inverse of f of x in the form y is equal to. Okay, so you have to determine what the inverse of f of x. Okay, you are given f of x is equal to this. Okay, remember a is 1 over 2. You have it to the power of x. Now from here, what you have to do is to get the inverse of f of x. Okay, before you can do that, let's change this to y. This is y. So you have y is equal to this. Okay, what you have there. Now to get the inverse of f of x, what you have to do is to exchange x and y. You exchange your x and y. So you have y there. You are going to have x is equal to, you have this to the power of y. Okay, you exchange your x and y whenever you are trying to get the inverse of a function. Okay, this is what you do. Now what you have to do is to get y, the subject of the formula. You can see y is the exponent, so you have to introduce log on both sides so that you can solve for y. Because y is the exponent, you have to introduce log on both sides so that you can solve for y. You are trying to make y the subject of the formula. So you introduce log on the left, and you also introduce log on the right. You can see log of x and log of this. Okay, you introduce log on both sides. You carry on, you have log of x is equal to, you drop the exponent down times this. Okay, this is what you do. I can close this for now. So you are trying to make y the subject of the formula. So you have to divide by log of 1 over 2 on the right and log of 1 over 2 on the left, so that this and this can cancel and you only remain with y. Okay, so this and this are going to cancel. You remain with y only. So you have y is equal to what you have there. Okay, this. So y is equal to this. You can see. You carry on. Y is equal to log of x to base 1 over 2. Okay, this is the final answer. This is how you write it. Now question 7.3. Let me get the question again. 7.3. Determine the equation of y is equal to h of x, where h is the reflection of f in the x-axis. So the question is 1 mark. In other words, they want you to reflect f of x in the x-axis and get h. Okay, so f of x again is equal to this. Okay, remember from the previous question. Okay, f of x is equal to this. Now, to get h of x is obtained by reflecting f in the x-axis. To reflect f in the x-axis, you have to multiply it by -1. Okay, when you multiply f of x by -1, this is equal to h of x. This is what you have to do when you are trying to reflect an equation in the x-axis. You multiply it by -1. So you carry on. What is h of x? This is h of x. Remember, you multiply it by -1, so you have -1 there. Okay, and so finally, h of x is equal to this, what you have there. Okay, this is what you have to do when you are trying to reflect a function or a graph in the x-axis. You have to multiply it by -1. Okay, as simple as that. Now, question 7.4. Let me draw a line here. Okay, now it's 7.4. The question is, how must the domain of g of x be restricted so that the inverse of g of x will be a function? Okay, the question is 2 marks. So g of x is this. G of x is equal to 4x squared, right? G of x is equal to 4x squared. This is a parabola. Okay, how must the domain of g of x be restricted so that the inverse of g of x will be a function? 2 marks. Okay, so let me show you this. When you have this is g of x, and you reflect it to find what? To find the inverse of g of x. This is what you are going to get. You are going to get this strange parabola. And this is not a function. You can see if you try to test it to see if it is a function, you are going to use the vertical line. And you can see it failing the test because the vertical line is cutting the graph twice. So if it's cutting twice, this is not a function. Okay, so this not a function because the vertical line is cutting it twice. The vertical line has to cut it once only for it to be a function. If it is more than once, it is not a function. So the question is, how must the domain of g of x be restricted so that when you take the inverse of g, you'll be getting what? A function. In this case, we don't have a function. So for you to get the inverse of g, which is a function, how can you restrict this domain? You can see the domain in this case is from -infinity to +infinity for this graph. It doesn't stop here, from -infinity to +infinity. So this is how you have to restrict it. Let's say you have this. You have now only this portion. Instead of 2, you have only 1. And you can see now the domain is restricted from -infinity to 0. If you restrict it this way from -infinity to 0 and you get the inverse, this is what you are going to get. The inverse is this. So the inverse of this is this. And you can see this is the function. right? Because the vertical line is cutting it only once. So this one is failing the vertical line test, and this one is passing the vertical line test. So this is the function. So if I restrict the domain from negative infinity to 0, the inverse will be a function. Or I can restrict the domain from 0 to positive infinity and get this. Let me close this. If I restrict the domain like this, from 0 to positive infinity, and the inverse is going to be this. And again, this is a function because it's passing the vertical line test. Okay, so actually this question has got many possible answers. Okay, there's not only one possible answer. You can restrict the domain in anyhow, as long as you get the inverse being a function. So for now, let's say the answer is, if you restrict from negative infinity to 0, this is x less than or equal to 0, you have all this, you are going to get a function. Or in this case, if you restrict it as x greater than or equal to 0, right? X greater than or equal to 0, like this, x greater than or equal to 0.